All right. So anytime during the discussion, if you have questions, you can ask them. All right. Just raise your hand and I'll hear it out. Okay. Um, let's see. I'll show you guys later the what anaconda looks like when we get to the part where we're gonna use it. But basically it's this one. Um, there's a lot of programs inside of Anaconda, not just the one that we're gonna using. We're gonna be using, which is Jupyter Notebook. There are other programs in there. That's why it has a big size. But what we're gonna use is something called Jupyter, right? So if you've heard about this, then that's great. So you have a kind of background on what we're gonna be using. Okay. All right. So let's go to our first PowerPoint here. The fundamentals of Python, first programs, and then yeah, we'll start with chapter one. So basically, how we go about this is we've had some discussions, right? And then we'll proceed to some exercises. If I feel that you guys still need some extra exercises, I give you some extra exercises. Also, sometimes I also give out assignments. If I feel that we need more practice in certain parts. So yeah. All right. All right. So let's start with something that's always asked, right? So you're in this course, data science bootcamp, but what exactly is data science, right? Does anyone have an idea? Just a rough idea. What do you think data science is? Any volunteers? None? All right. So I'll guess I'll pick out someone. Let's see. I want to hear from Neil.
Uh, this is just opinion ko lang po kung ano po yung sa data science. Maybe using data to get an idea of how to probably solve a problem or get an idea on how to approach a problem. Yun po. Yun na po.
All right. So that's somewhat correct. All right. But it's lacking a bit. So data science is actually about turning data into something like you can make action of. So it provides insights and also provides predictions based on past data. So that's what data science is. And where do you usually see this one being applied? It's being used a lot by your leaders, right? Our bosses, the decision makers. You're gonna be pitching to them the result of your research, all right? That imagine yourself first to be like imagine yourself to be creating a product, for example, and then you're having a research where you have theories as to how if our product was made in a certain different way, this might be able to sell more compared to the other one. So how are you going to test this one out? So you might be saying that there might be a difference because of where we release the product. Like, for example, there's more sales in this certain part of the area versus here. So you might be studying why it's much better, it's much higher sales over there than here. Or you can ask for a survey. So um, if you've noticed, there are some websites that are also always asking for surveys. It's because they're collecting data, all right? So it's actually free data that they can use to improve their products. What else? So those rates that you see, like rate our app, rate our website, that is also a kind of survey that they will use to um, improve their product. What else? So in some websites, you might not notice this, but they are gathering data on where users usually click. So they call it a heat map, and that data reveals where the user is usually looking, all right? And with that data, they can modify a bit their website, so to speak, um, so that ads near to those areas have higher rent, so to speak, compared to other areas, right? Because it's it's a big hotspot there. All the visitors almost always go to that spot. They're clicking on something on that spot, and that's prime real estate really for ads. So that can be used, data science can be used in that manner as well. All right. You can create heat maps based on users' clicks. Okay. Great. Thank you for that answer. So basically, we're going over a little bit about computer science here. We're not directly starting out with Python, right? But we're not going to be dealing with too much about this, like history, hardware, software, not so much. We're just going over them really quickly. So most important aspects that you have to understand are algorithms and information processing. So algorithms is basically just like a recipe or instruction. You've heard this one before. I know it's been discussed in high school, but it's always being like taken for granted that we've been using algorithms a lot. You've been following cooking recipes, you've been following diet plans, you've been following routes if you're into like jogging, so to speak. All right. So algorithms is basically just part of our life, and it's actually language agnostic. So when you say language agnostic, it doesn't matter what language you're speaking of. It can be translated into different kinds of languages. All right. Um, so imagine, for example, a certain recipe, you can translate it into different languages. Uh, you can still create the same food. That's what I mean. Information processing. This actually just refers to just transformation of data. All right, we're gonna transform the data into something that um, your program can use to make um, the outcomes that we discussed earlier, like predictions, like insights, right? You're gonna create graphs where you show that this is the trend line here, and if you follow this one, this will probably be what will look like in the future if we keep on following this one. So something like that. All right. Let's see. So this is just an example of a algorithm. Where's my laser pointer? Yeah, here we go. Um, Computing agent, algorithm. Let's just skip that one for now. Let's see. Another example. So in these slides that I am skipping, you guys are free to actually review this one in your own free time, right? If we try to go over each slide, um, and I think we can, but it doesn't really uh, like you know useful for us at this point. Information processing. So this is just basically the start or the basic process of how information is transformed. So you start with the input and then we'll transform information according to some well-defined rules. So it looks like it's just one step, but this part here is actually where you have to like be very specific with your rules. For example, you have data that has a lot of zeros. So how will you treat those data with the zeros? Do you treat them as invalid data? In case of invalid data, do you remove the entire record or the entire column or just the single data? So you have to know what you want to do with those kinds of data. What else? Is the format of the data in a way that you can use directly. So some data is actually presented in CSV. So if you use CSV before, it's comma separated values. Each value is separated by a comma. Um, and then there's like a certain line in the CSV where it indicates what each value is or each position, um, what each value is position is for. So that's what a CSV is. After that, we'll go directly to the output. But we say output, but basically it's just another stage as input to another part in our process. So I think we can add some more into this. So like, um, let's see. We can put storage in between if we want. You have to decide whether you want your information to be temporary or permanent. If it's permanent, then it will usually be in a sort of database that you can access anytime. Um, if it's temporary, then it can be just as easy as, it's in your RAM, it's in your device, and it will be gone the moment that you close the application. So there are those things. Let's see. How to represent many other things. All right. So these are some examples of data that we can collect. So we have images, of course. We have music, human speech, video. You can convert these things into actual numbers that you can then analyze. All right. Um, So yeah. So what other data do we have? We have text data. So when we say text data, this includes everything from Facebook posts to Twitter posts to journals, scientific journals to magazines, as long as it's text. Um, we also have, of course, if we have text, we have numeric data as well. So numbers basically. Um, Stocks, if you think about it, are just basically all numbers, stocks, and it just keeps on updating in a very fast pace. What else? Um, hmm, we have GPS data now. So if you want data, like if you want something to do with GPS data, then that's available already. Um, like which route is most used by travelers or which route has more traffic. You can use GPS data for that one. Um, what else? We have metadata. So metadata is usually in all files, kind of like um the description of what the file is, where it's made, who's the author. You can collect those kinds of things and compile them into one big um resource later on. Okay. So that's it. Let's go to the next one. Hardware and software. We can basically skip this one. I'm sure you guys already know what a hardware and software is. Let's get this one. All right, ports and networks. So some don't actually have an idea what ports and networks are. So let's discuss this for a moment. Um, I like using the analogy of this one for like let's see. You can treat ports as kind of like doors, right? And those doors lead to different services in your device or applications, so to speak. Um, and in those, you can send and receive data. All right. So you can think of it as like an endpoint in any kind of communication. So if you're communicating, for example, in a um, Facebook Messenger, for example. So there's a different application for that one, right? And it's connected to a certain port. When it sends a signal, it will travel to the internet and will go directly to the end port on the other device that's the same with where it came from, right? So that's basically how computers understand where data should go, right? So that it won't get lost. Networks are basically just the highway, all right, where all the data is being passed through. So that's one analogy that we can think of on what networks are. Um, yeah, basically. For hardware, so RAM, we have random access memory, processor, we have some external or secondary memories, right? Um, Yeah, I'm sure you guys haven't used this one before. Like most of when my students are a bit young, they haven't used like the floppy disk, the forgot the name of the big one. Um, some of them don't even have used CD before, optical disc. So what other thing do we have? We have the newest right now is an SSD. We also have a M.2, if I'm correct. We also have DVDs before, Blu-rays. If you want some very big space, we have a NAS. So that's a network access storage. If you don't know. What else? The most common nowadays is the cloud storage, right? Actually, USBs are beginning to go out of phase because of cloud storage. And almost everyone everywhere already has connection to the internet one way or another through data. And that's basically the goal of every other nation because they want everyone to be connected. What else? We also have tape drives. If you've heard of that one before. Usually you can find this one in like large scale backups of systems. So whenever some big companies as big as Facebook, for example, stores their data for long term, it's usually in these kinds of drives, tape drives. So they're not really like so um for the public. You need like, you know, only big companies can buy them. This is a rough look at what is inside of our computer memory. So as you can see, it's just basically ones and zeros. If you go into the technicality, these ones and zeros are actually just transistors turning on and off. Um, they just made it too small that they keep on compressing. That's how we develop technologies nowadays. They develop different kinds of architectures, but it's still in the end just ones and zeros, or basically just transistors turning on and off. Um, let's see here. Machine code. Let's see. There's nothing really that's important here. Let's go. Text editors. So, you can actually make a program using Notepad. That's true. Not just for um one language, for any language really. You'll just save it as a different extension. So for example, in Python, instead of .txt, you'll save it as .py. So automatically it becomes a Python script. If you save it as .cpp, it's stored as oh, your device will recognize it as a C++ file, right? But basically it's just a notepad, so to speak. You can even open it in a notepad if you want. as long as it's not yet compiled or it becomes an exe file. So that's a different thing. We have something called a translator, and this is the one that's responsible for converting our program into an executable code. All right. It's also the one that checks for syntax errors. We'll learn more about syntax later on when we discuss Python. All right. Let's see. If stars are found by the system. Yeah, I don't think we have too much use for this one for now. High level programming languages. We call them high level because they resemble more to English rather than like a foreign language to us. So if this is your first time, your first experience in programming, right? You're not gonna be able to like feel the difference of what a high level and a low level programming is because Python is your first language. But basically, Python is the easiest language to learn because again, it resembles English a lot. It has less of the things that you have to um, always make note of in order for your program to work. Like for C++, you always have to end statements with a semicolon. If you miss one, it won't work. Um, it also has like what mm, requirements with how you group basically your code. But it's just the same with the others. But with Python, it's a lot easier because you don't have those extra characters that you need to always make note of. Python just uses indentation to indicate grouping of your code. So we'll learn more about that later on as well. This is the basic flowchart of what it does. So from the text editor, it goes to the translator and then automatically to the runtime system, or basically when your system is running. Then you can ask some inputs from the user. If there are error messages, it will come out here. And then if everything is good, then the program will create some output, whatever that output is. All right. So it's just a basic flowchart. A slight history of computers. So it actually goes back way, way, way back before 1800 to the discovery of mathematics, I think. Yeah, first mechanical calculators. Yeah. So let's see. Abacus was obviously considered one of the first computers. It's just for like I don't really know how to use an abacus, but I heard it's up until it can do the four basic operations like plus, minus, multiplication, division, but I'm not too sure if that's the limit. Um, we have the Pascaline, all right. At the time that this was made, I remember when this was discussed before that at the time that this was made, it was very high tech. Like only the elite can have this one. And if you have this one, you would need to be very good at what you do because only the knowledgeable can actually use this one. Like you need in these days you need like a degree to use this one, so to speak. But this actually had a lot of limits. Like for example, there are just there are 8 digits that you can do. Um, so it has a limited range, it has a limited operation, but it was a marvel at the time because it does things automatically, right? So it's a far cry from what we have here um these day and age, right? Um, but if we talk about if we have like if I want you guys to describe a technology now that exists now that is in the same condition as the Pascaline, what technology would that be? Can you guys answer? So there's actually quite a lot that's in this state where only a few can use. So can you guys give some? Let's see. Any volunteers? None? Why are you guys so quiet? All right, so I'm gonna pick one. Let's see. I want to hear from Catherine. Do you have any idea?
Yeah, I don't know, but wild guess iPads
iPad?
or laptops.
Kind of, yeah, but a lot of people like can use that one even without special degrees, so it falls off a bit to like what I was asking for here. What else? Let's try Paulo. Let's try Paulo. If you can hear me. Hello? All right, let's get back to Paulo later. Anthony, where are you guys? All right, let's go to Gabby.
Hi po, wait, paano po ulit ano po ulit yung tanong?
So,
Exactly,
like,
medyo na-cut off po sa una.
what technology that exists today that is in the same state as the Pascaline before? Like, only the elite can use it, only the ones with high degrees can use it, a lot of
Um,
credentials, something like that.
siguro po parang any device po ba? Or any like computing
Yeah,
device?
not really a device, more like technology.
Oh, tech, wait.
That's okay. That's
Wow,
okay.
it's hard to think of one.
All right. So, okay, there's a reply here. Sorry for the delay. Drones, yes, kind of. That's actually a good answer, Anthony. So, not a lot of people actually can use drones, but these days it's getting a lot cheaper and a lot more people can just use it directly because there's not a lot of rules right now where it's not allowed to fly here like that. So, it's kind of free space in the air currently. So, in a way, yeah, we can say that drones apply to this one. Um, yeah, good idea, Anthony. Um, I think I went through all of you. I'll just get back to you later, Gabby, for a different question. Um, so one technology that I can think of is actually quantum computers. So it's been talked about a lot, and there's only two successful quantum computers made, from what I know. One is in Google, one is in Microsoft, I think. So those are the only two quantum machines that we have right now. And the potential of it is actually endless. Like if a if a transistor has an on and off, right? One and zero. Basically what a quantum bit can do is instead of two, it can do eight from remember, it can do eight values with just one bit, if I remember correctly. So with that, the computing process, the speed will scale up as well exponentially. So there were reports where problems that weren't solved by computers before was actually solved a lot easier with quantum machines because it can handle instantaneously multiple um, instances of problem solving. It's kind of hard to put into words right now. Um, I haven't really used one. If you're thinking about if I've used before, but no. Okay, that's enough for that. Let's see. This is like I can't read this one. Oh yeah, this is the loom thing. From what I understand, looms are kind of like a fabric, so it makes some kind of fabric, from what I understand. So yeah. History of electronic digital computers. So we have these people here. Of course, they are all important, but right now it's just for discussion purposes. So we have, I think Alan Turing will be the one most famous because his name comes up a lot in movies, right? Um, Especially when it comes to like robots or AI. So his names always come up. What else? We have, let's see, Mark 1, ENIAC, ABS, PC. Mainframe computers. We can discuss this one. So these are the computers that were so big that they fill the entire room. All right. At this point, transistors did not exist yet. That's why they were so big. It was the discovery of the transistor that started the whole miniaturization of all the devices that we know today. Because before that, they were using vacuum tubes to indicate ones and zeros, right? So it was a very big machine and it was very complicated to use because it involves high voltages, whereas transistors now can operate very accurately, right, to minute changes in voltages. So that's what you have in your phone right now. Okay, a lot, millions of transistors turning on and off simultaneously. Okay, let's go. Assembly languages. So this is one of those low-level programming languages. Um, Basically, you are speaking directly in the language of computers, ones and zeros. Would you like to use this one? I do not recommend it. It's very hard. It's a lot. There's it's very error prone. The only words that remotely resemble English that you will see are things like add, output, subtract, what else? If I remember correctly. So you can't even define variables. So you have to use gates in order to get the result that you want, like one and one, it becomes one, one and zero becomes zero. So you have to take that into account. It's very annoying to work with. I've used this one before, and I'm actually very happy to be working with higher level programming languages. It's a lot easier, a lot less stressful, but it doesn't mean that no one's going to use this one because assembly languages, if you think about it, um, you know how those softwares that you can download that are already pirated or cracked. So what those people do with malicious intentions is they actually go the opposite way. They start at analyzing the assembly code because once you convert your code into like an exe file, it basically becomes readable to us because now it only is understandable by the computer. So what they do is they analyze it in reverse, kind of like reverse engineering. So they start with the assembly language, and all they do is basically just um, intelligent guesses. Like they change a certain part, this will happen, right? A lot of trial and errors, so to speak. But it is actually possible to do it in reverse. So do I advise it? No. Should you do it? No. Definitely not. Let's see. We have assemblers, compilers, abstraction. Yeah, we need to discuss what abstraction is. Now, abstraction. Let me see what you guys think of the word abstraction first. I think I ended up with Gabby earlier, so let's start with Gabby for now. Gabby, what do you think of the word abstraction
Um, in this context po siguro,
in any context?
could it be like um making things more like breaking things down into something more simple pa ba?
Breaking things
Because like
down. Mm, can you expand on it?
I'm not sure po though, pero maybe it could be like kunwari po may you have like a bunch of siguro complicated info tapos pwede mo po siya i-simplify
All
just like
right.
in abstract
Okay.
or
All right. So, in a way, you're kind of correct. I guess you're just lacking the words to describe it perfectly, but in a way, you're correct. So, thank you for that, Gabby. Let's go now to actually, let's go full circle. Let's go back to Neil.
Same question, sir.
What do you think of the word abstraction?
Um, Same din po nung understanding ko is parang hina-hide po yung complex. Parang for interface purposes, parang easy to understand po for the user.
Mm, right, that's good. That's a good insight. Thank you for that, Neil. Okay, last one. Let's go to Catherine.
Yeah,
Hello?
sorry,
Yep, yes.
but yeah, so para siyang painting.
All right, yeah,
Abstract.
abstract painting.
So
So
yeah,
what do you see?
surface
Yeah, that's correct. So what do you
surface
think when you
level.
see abstract painting?
Parang surface level siya. Pero pag dive mo siya, meron siyang mas malalim na purpose or meaning.
Right, that's correct. So it's just put into different words, but if you translate it, it's really the same. So abstraction really is just like hiding the complexity, all right, into something that is a lot more user friendly to us so that we can just anyone can just use the product, right? So one example of this that I like to always discuss with my students is the car. All right, let's go back. Let's go to the car. Okay. What do you need in order for you to use the car? You need what? You only need to know how to use the brakes, the gas, the shift, the gear shift, the wheel, some traffic rules, um, basic maintenance like gas, water, oils, right? Those kinds of things. So it's rather simple, right? Anyone can do those things. Even high schoolers can do those things. But uh, what's actually hidden underneath are what? The engines, right? The how do fuel injections work? How does the differential work, right? Why is it that when you turn the car, it doesn't like turn in a way that makes the other wheel lag a bit? So that's the purpose of the differential, if you guys didn't know. Um, what is the purpose of forgot the name, the shaft that connects the front Mm, the front the front drive to the rear drive, I forgot what's name. Um, but the one that's in the middle that's spinning to connect the two parts, the two axles so that they spin together, making it into a four-wheel drive. I forgot the name of that one. But those kinds of things are abstracted from us because we don't actually need, right, for us to know in order to use the car, right? What do we want to do? We want to use the car to drive around, go to different places, be like how do I say this? It's more convenient, right? That's what we want to use the car for. We are not really using the car because we know how the engines work, all right? I mean, we know how to maintain them, but their complexity is abstracted from us. So that's the main point of abstraction. So it makes things that looks complex a lot more easier for us to use. So yeah, all your answers earlier were kind of correct, basically. Um, so yeah. All right. Here, it was in the late 1950s, was the invention of the transistor. So this is a solid state device. After this one, they started experimenting and eventually it came about with the integrated circuit, the IC. So this is smaller, faster, less expensive hardware. And these are usually those black things that you see when you have your phones repaired or like laptops. If you open them up, you see on the motherboards, these usually are the black square things that you see. So those are the integrated circuits. All right. Then mini computers started appearing after the 1960s, right? So these processes are just byproducts of what mini computers can do, but there's really no need for us to know what these things are. Douglas Engelbart created the mouse, all right? So it was actually a revolutionary invention, the mouse. Next is 1975, Altair created the first microcomputer. All right, then we have MS-DOS. How many of you guys have used MS-DOS? Raise your hands, or just a thumbs up. Thumbs down if you haven't used MS-DOS. All right, so that's a thumbs up from Sir Anthony. Gabby's a down. For me, it's a thumbs up actually. So I guess that shows our age. I'm sorry, guys. I guess that shows our age. So yeah. MS-DOS was actually very difficult to use before. All you see is a green screen, and then yeah, I remember saving before in Excel was actually quite of a hassle because there's no confirmation that you have saved the file. So if you forgot to save, then it's gone completely. Unlike what we have now, if you forgot to save, there's an autosave, right? If there's a sudden power failure, there's a backup that the computer has saved some part of your work, so you're not gonna be doing everything again all over. So there's that. So technology has come a long way, really. Then we have LANs, and then ARPANET, what grew into what we call the internet. So by the way, this is actually interesting. So we have a lot of ways of connecting to the internet, right? Um, we have the basic Wi-Fi, and we also have the LAN cable, right? So, what other ways do you think can we connect to the internet? Right now, so the basic things are Wi-Fi, we have LAN, and we have data. But what else? Can you give me some more examples for us to connect to the internet? Right, so I guess, okay, yeah, Gabby.
Um, I think may nakita po ako dati na parang dial-up connection po. Like may itatawag pa po na phone number para makakonect.
Yes, that's correct. So that's using the phone lines, right? Very good. But that's fairly old technology. But I remember using that one before. Yes. Hotspot, in a way, yes, that's correct. Yeah, that hotspot is a kind of technology you can use to connect to the internet, but it's still using mobile data for the other one. Um, yeah, so it's still correct. What else?
Yes lang po. QR
Mhm.
code.
QR
QR
code.
codes.
Mm, I don't think so. QR codes are used to access an already existing connection. So I was looking more of like different ways, actual ways to connect to the internet. So the QR code is kind of like just the password to access the way to access the internet. So Yeah, I don't think we can consider that one. No answering of phone calls during dial-up connections. Yes. So the moment that someone picks up the phone, your connection is lost. So if you were downloading a movie, let's say you're downloading a movie of 700 MB, which is pretty big before when you have dial-up, it will take you hours. So if it was cut off, then that's goodbye to those hours that you've spent downloading that movie. Actually, there weren't a lot of sites before that you can download movies, so we have to use something called the IRC. So for those guys who know or you still use the IRC, that's great. It's a very old way of chatting. It's called an internet relay chat, if you guys want to know. I think one still exists nowadays. Just want to share with you guys. Yeah, this one. So I think they still exist. I don't know if anyone's here, but I think it still exists because it's up to 2025. So yeah, they're still there. Um, Not really a lot of viruses back then. Since it was still the internet was still pretty new. Viruses just came along roughly around 2000s. That's when it there were a lot of viruses coming out. All right. Okay, there. All right. So thank you for your answers, but here are some other ways that you can connect to the internet, other technologies that you might not be aware of. So usually you guys are using Bluetooth, right? To connect to your headphones, to connect to your um other smart devices, but you can actually just use also Bluetooth to connect to internet as well, kind of like how the hotspot works. So that's one thing. We also have power over Ethernet. So this is an Ethernet connection and also a power connection at the same time. So if you've ever seen like um, CCTVs where you might be wondering, hey, where is this one connected? Like, I don't see any power connection. There's only one wire. It's not plugged into anything. And that is because the power actually comes from the internet wire itself. That's what we call PoE. We also have Ethernet over power. So that's the opposite. All right. So it's Ethernet is connected to the power line. So if you have um like for example different outlets, all right, you can actually connect to the internet through your outlets or something. So there are actually products that does this, EOP, EOP products. If you guys are interested, that's not the one that I'm looking for. Ethernet, Ethernet over power. Yeah, products. Let's see. In US, they use power line for internet connectivity. Yes, that's also correct. Here we have things like, I wonder if we can search it in a shop. Let's try Shopee. Power line adapter. I guess it's this one. Yeah. It's something like this. So you see that? There's two LAN cables there or something like this. So you connect them from one end of your room and then the other one to another room. And then basically you have an internet connection just using your power system inside your home. So if you think about it, it's a lot cheaper if you were to like put wires all around your house or to migrate like a router to a different room. In some cases, this can be a cheaper option for you. All right. So I'm not trying to advertise this. I'm just showing you guys what technologies are available. All right. We also have like there's a lot of companies doing this one nowadays to help market their products. So Ethernet over cable. So if you have cable, they also provide internet services through cable nowadays. So we've also received some of that offer here where I'm from. Um, so yeah. Virtual reality. So there are some technologies out there already where VR is used. Like um, the most famous one, that the most um, trending one right now is Oculus Rift. So it's actually pretty nice. So there are a lot. It's usually used for games, but there are now certain applications for therapy. There's also for military use, right? So it's it's a good like um field to be in these days as well. All right, so let's go to the World Wide Web. All right. Based on the concept of hypermedia. When you say hypermedia, it's just a combination of different medias. So when you go to a website, what do you usually see? You have images, you have music, you have video, you have all these other stuff connected to other stuff. Hypermedia. That's what we call. We have HTTP. This is called Hypertext Transfer Protocol. Mm, eh, Without discussing too much into web development, think of HTTP as um, kind of like the rules that you have to follow in order for you to connect to another device. If you don't follow these rules, then your data will never get to the other side. Okay, you have to follow this rule. HTML is the hypertext markup language. So this is not a programming language. HTML is basically the backbone of every website, right? The backbone, meaning everything else is attached to the HTML, no matter how complicated the website is. So a short, um, no, not YouTube, maybe something else, like Facebook, for example. All right, so if you go to Facebook and then go to the developer tools, you'll go directly here to elements and you'll see the HTML file. And it may look like it's just a few lines of code, but if you expand this one, is actually a lot more. See? So it might look confusing, but if you understand how HTML works, you can kind of filter out the things that you want to see and then realize that most of them are just containers. Again, this is just for um, the backbone. Everything else is attached to the HTML. The styling, the coloring, the images is all attached here. So if you're interested in that, then you can also try web development. It's a nice field to be in nowadays. Um, is it hard? Yes, as hard as any other programming languages that you're gonna encounter on. Let's see. The World Wide Web. So basically, the World Wide Web is just a connection, an interconnection of different computers and servers. That's basically what the World Wide Web is. And we are really dependent on what the undersea cables that are connecting different countries, right? So I think there's a treaty to that where everyone has to help maintain those undersea cables because it's the lifeblood of the internet, right? Um, there are some redundancies, like if this line fails, there are some other ways for us to still connect to a certain country, but you know, we're just relying on these undersea cables. We have satellites right now. It's just beginning to develop, like um what's that called? That new thing that just came out, the one with the satellite that you have to buy once and then just pay monthly. They give you a dish and then you can just connect anywhere as long as you connect it to, as long as you point it to the right satellite. Um, we got the name. I think it was from Tesla. Starlink, yes, that's the one. Thank you, Anthony. So Starlink, I asked before, so it was around 20K for one. But it's really nice, you can connect to anywhere. Um, since since the signal is in the lower frequency, so it can go through, if I'm correct, it can go through rain and clouds. So even though it's raining, you can still connect to the internet. I'm not too sure about that, but you can verify that if you buy one. But yeah, it's a nice technology for those that want to be in mobile. Yeah, web applications. Yep, we have a lot of web applications already made. Like, let's start with the old ones. So we have the Netscape Navigator. We have what other applications do we have? We have Yahoo. Yahoo still exists today, but it's owned by Microsoft already. It was bought. We have AOL, if you guys know what AOL is. GeoCities. Before Google, there was Alta Vista. There was Ask Jeeves. So those are different web applications that we can have. Um, Basically, I'm just sharing to you guys what existed before, because now there's just too many really to keep count. What else? We have eBay, we have Amazon. Amazon wasn't as big before, but you can buy things online, so that was great. I remember buying something from Amazon before. It was really scary because you have to input your credit card, and it wasn't really that common before. So it was a really scary experience, you know, doing something like that where no one around you has done it before. So let's see. There were PDAs in the early 2000s, but it wasn't really used a lot. It was mostly used by doctors, um, from what I know in movies and series that I watch. Then here comes Steve Jobs with the Apple, the iPad, and then the social networks came up. So we have the Facebook, we have the Friendster, we have the 6 Degrees, we have the professional Facebook called LinkedIn, we have MySpace. If everyone is still using MySpace. I don't know if you guys have used Friendster before, but I have. So it was kind of annoying because some pages were filled with too much graphics that um it took a while for it to load. But we had nothing else before. Um, Big data. So big data is actually a important concept. So people usually underestimate how big data is, right? So maybe you've seen some documentaries where a day in operation in the current age, we've generated more content, more words than all of history. So that's pretty big, right? If we were to like describe this one in terms of video, right? Like volume, okay, data in terms of volume, how big is the data? So, um, some data sets can range from terabytes to petabytes. So have you ever heard of petabytes? I'm sure terabytes is becoming a common term now, but petabytes, right? Petabytes is something else. It's like an entire tier on its own. So if I were to ask you guys how big is a petabyte, right? Like I know you can give me the number, but I want you guys to visually like put it into perspective, right? What a petabyte is. So who can guess? Any guesses? Let's go with Paolo. Hello, Sir Paolo. All right, so we'll get back to you later on. Let's see. How about the others? Catherine. Okay, the question. So I want you guys to like, if you guys heard of the word terabyte, like as a size of hard drive, right? Um, the next level of terabyte is actually petabyte. So uh, I want you guys to give an example the perspective on how big a petabyte is. So just for comparison, a terabyte is what? Let's see. So a terabyte is 1,000 gigabytes or 1 million gigabytes. A petabyte is 1 million times larger than a gigabyte. So yeah, can you put that into perspective? Like how big is that if you were to put it into perspective? So a lot of people actually underestimate this one. Like, hey, maybe the petabyte is the next one. So it's not really that easy to develop. Developers, the companies are having a hard time actually to 200 million songs. Yes, that's correct. So I've read that one before as well. Or if you were to say in terms of video, right? So a simple HD video, for example, 1080p, not even 4K. So that's around 150 to 200 megabytes, right? 350K movies. So let's see, 150 to 200 MB in size. So with a petabyte, right, with an HD movie of 1080p, um, a single minute, right, it's around 200 MB. So if you were to store that one, okay, in a petabyte, that would be 5 million hours of content. So if you were to convert that hours, that would be 578 years. So yeah, why why would you like want to watch that kind of content, right? So what can we do? We can use technology in this case. We can use data science in this case to analyze those videos for us and then process the information that we need. This is the moment where computers really shine because they like repetitive stuff like this one, where they don't rest, they just keep on doing the work. All right. So yeah. And finally, we've come to Python. So this was invented by Guido van Rossum, and it is a high-level programming language, general purpose programming language, but basically it's famous for data science and data analysis. Okay. Um, Basically it just became famous for that because at that time the developers were using Python. So if they were using a different language, then it might have been different altogether. But we have Python here. What other programming languages can do, Python can do as well. And what Python can do as well, other programming languages can do it too. So if you can do data science in Python, you can also do it in other languages. It doesn't mean that you just have to exclusively just use Python for data science, right? So there's a lot of different ways you can use Python. You can use Python for creating games. You can use Python for creating websites now. So it's relatively new, but the technology is there. You can use Python for creating servers. So we discussed that one as well in web development. So that's a possibility that you can use Python to create web servers, databases, those kind of stuff. But yeah, that's why they said it is a general purpose programming language. All right, and here's the link to the official Python website. Okay, let's see. All right, so I guess this is the part where we can um, have a proper start with Python. All right, so I can see that it's around 240, right? And this is a 4-hour class. So let's have a quick break, 15 to 20-minute break, and then we'll get back here and continue discussing our lesson. All right. So let's see. On my watch, it's currently 2:45. So I want you guys here to be back by around 3, right? So don't leave the room. I'm just gonna turn off the video and the audio. And yeah, Have a good break, and I'll see you guys later. Okay? All right. All right. So are you guys here? Give me a thumbs up. All right. Thanks. Okay. So I hope everyone had a good break. Um, so let's continue, right? Okay. So we're gonna start with Python. And let's see, let's just skip this part. So this is basically what a Python shell is, right? So you're gonna be using the shell to kind of like interact with the computer. So this is your sort of way to communicate with it. And you will get this one if you will install Python from its website. So you'll get an IDLE. But we won't be using this one in this case. All right. So for Anaconda Navigator, let me see. I'll just switch my share screen. All right. So when you open up Anaconda Navigator, this is what you will see when you open it up. So we have some menus here: home, environments, learning, community. So if you want to explore these things, there are some basic, and I think some are paid as well, tutorials. There's a community if you want to explore some communities as well. But basically, we're just going to be playing around with home and environments. So if you go to home, I want you to scroll down. As you can see, there's a lot of programs included in Anaconda Navigator. But what we're going to be using is this one, the Jupyter Notebook. All right. Now, if you click on launch, what will appear next is something like this. So after clicking launch, it will load. Depending on your device, it may load quickly or it may take a while. But after it loads, it will show something like this. This one. All right. Now it will show you an explorer in the browser, but this will have access to your device. All right. So as you can see here, this is in my desktop, PCC Data Science and batch 18. That's you guys. So it has access to the files in your device. So after locating your folder that you created, right? You can just navigate as easily as this one. So double click, just like any other explorer. Okay. What you'll need to do next is you're gonna create your first Jupyter notebook. So you're gonna see something like this, a new button. In other browsers or in different versions of browsers, it may have a different user interface, but the basic things that you see will almost always be the same. It may have a different look, but it should still be there somewhere. All right. So click on new, and then you'll have these things to choose from. So I want you to choose Python, Conda, environment, base. Okay. Now, right now, it was really easy to create a Jupyter notebook for Python. Right. This is what we call a Jupyter notebook. Currently it's untitled, right? This is our notebook. You can click on this port to edit the name. So I'm gonna name this one batch 18. Um, lecture notes. All right. And then click on rename and it will be renamed. Okay. It has an autosave, but if you want to manually save, you can just click on file and then save all, and that will automatically save it as well. Um, let's see. Mm, Yeah, it's like, yeah. So yours has a slightly different, um, yeah, that's okay. IPY kernel for this one, it's just the same. If you click on Conda environment base, it's the same with IPY kernel. That's okay. All right. If I go to your Jupyter notebook now, let's discuss for a few minutes how to use this one. So, in the middle here, you have your cell. We call this a cell. And then this cell actually has two modes. Let's see. Right. So it doesn't really show, but if you click on outside, the blue is, or it doesn't really change. All right. So the highlight here indicates what cell you are currently on, but in different versions, it changes color depending on the mode. All right. When you are inside of the cell, your cursor is inside of the cell you are in. Um, in how do I call this one? All right. So you are in write mode. Um, basically you'll be typing out your code inside the cell. And then if you click on outside, you'll be in command mode. So meaning all the shortcuts that works for Jupyter Notebook will be accessible here only in command mode. So for example, while in command mode, I'll press A. If I press A, it will add a new cell above it. If I press B, it will add a new cell below it, right? If you want to delete a cell, just double click on the letter D and then it will delete it. Or you can use these shortcuts here at the right. So if you're having trouble memorizing the shortcut keys, you have these options at the right. So you can start cell below, above, or delete. You can even move cells up and down if you want, depending on how you would do it. Next is on the write mode. Now in the write mode, there are three ways that we can write. We can use code, markdown, or raw. So usually code is, just for code, Python code. But for markdown, this is usually a styling. Um, Markdown is used for styling text. So for example, if you put a hashtag at the beginning and then title here and then run markdown, set this one to markdown. You can set each cell into different modes like code, markdown, or raw. But usually we'll be dealing with code or markdown. So this is what that code will translate into. If you double click on the cell, it will go back to its equivalent markdown. But if you run the cell, right, it will translate into its equivalent markdown output, like this one. There are other things that you can do, like with the dashes. So the dashes are used to indicate the list. So if you run this one there, you see it will create a list. So what is this used for? Markdown is usually used for to discuss the topic before it or the topic after it, to describe your code, to describe your graphs, and those kinds of things. So this is actually what makes Jupyter Notebook a lot easier to learn because you are explaining at the same time you're writing code, and it's a lot easier to present your research this way. So again, it's just a matter of preference, but for beginners, this is actually one of the easiest. There's less things to distract you on in the user interface. If you were using, let's say, for example, Visual Studio Code, there's a lot of um, things on the side there that will distract you from creating your code. So that's for Markdown and code. Um, let's see. If you want to run your code, by the way, you can just press play. So this will run cell in advance. Um, if you want to run everything, you can select run and then run all cells. So that will basically run everything from the start up until to the end. All right. Now it may seem that each cell is not connected to the other, but actually all the cells are connected in a way. So once you run a certain cell, if you have variables there, it's stored already in a memory and it can be connected to the other cells. So why do you want to separate cells? Well, let's say, for example, you have some code here, code, right? And then you have some markdown here. I forgot the shortcut for markdown. But if you set this one to markdown, okay, let's say this is for explain, right? And then you have another set here, another cell for another set of code. So in this way, different cells can still be connected, even though they are not in the same cell, right? Um, for those of you guys that don't have Jupyter Notebook yet, you can use an online one, a free version. So it's actually called collab.google. So if you go to collab.google, this is a free uh, Jupyter Notebook resource. If you click on Open Collab or any notebook, um, the notebook is automatically saved to your Google Drive. So make sure that you are signed in if you want to save your work. If you don't, then that's all right. Okay, so as you can see, it still looks pretty similar to what we have here, right? So if there's any instances where you cannot install Anaconda, you can just use Google Colab, all right? So it's still the same thing as with what we discussed here. It has command mode, it has write mode as well. See, even the shortcuts working the same way. A, B, or below, and then double D. Double D is not working. So you just need to press the trash can icon. But the difference is that this is connected to a server that has a certain RAM and disk size, right? So this is a shared device. A lot of users are sharing this device that are also running Google Colab. So if there ever comes a point to where your program is resource intensive, then I suggest you use the one from Anaconda because it uses your device. Whereas Google Colab that Google is using an online computer that's shared by everyone using this computer. So um, basically, it won't run as fast as you might think. All right. So we also have code and text here. So code markdown will also work here, I think. Michael. Yep. So this is the code. This is the preview of what the code will do. And then if you like, yeah, run it, it will show you the output like this. All right. Let's see. It automatically saves, of course, to your drive. And once this gets full, by the way, so right now it's really low, but when you are running the program, it gets full really quickly. Especially if you are dealing with large amounts of data. All right. So imagine an Excel file with thousands of rows. So something like that can trigger this one to crash. All right. Let's see. Let's go back now to Jupyter Notebook. What else? You see this one. It's called the kernel status. So this is how you know that the Jupyter Notebook is still working on your code. Um, if you run something that takes quite a while to load, this will turn black, all right? And when it turns black, it shouldn't really take that long, but when it does turn black for quite a while, that's the time that you should be wondering whether the program was still running or not. So odds are if that turns black for like 1 minute, 2 minutes, then turn off the program. So interrupt it here with the square button and then try to fix the issue. Okay, what else? Um, you can also, if that is that, you can go to kernel here and then restart kernel. So that's what you do. Here in Google Colab, you have, hmm, I think that's about it for Jupyter Notebook and Google Colab. I think we can continue now with our lesson. But in in this case, I'm just going to be using Anaconda. All right. So I hope you guys will be able to install it by next session. And hopefully there won't be any errors on your device. All right. So have that one as your assignment. Okay. So here we see our first function in Python. It's called the print function. So in Python, inputs are Python expressions or statements that's stated here. And what you see here is also the syntax or basically how you will use the function. It has to be in this specific format in order for it to run. So syntax is kind of like the grammar, right, of the programming language. So for example, in the English language, we have um, grammatical rules that we have to follow, right? Like we have subject verb agreement, we have um, let's see what else. We have phrases, we have conjunctions, those kinds of things. The same thing goes for syntax in or grammar in programming language. So you have to follow some certain rules in order for it to run. So whenever you're dealing with functions, right? In Python, you have to declare first the name of the function, followed by an open and close parentheses, and then the expression, right? Whatever that expression is. It doesn't always mean that it's just a single number or a single or a letter. An expression is something like something that can be evaluated into one. So for example, if your expression is 3 plus 5, so that's an expression, it will become 8 afterwards, and then it will show here as high 8, the number 8 example. On that note, let's discuss first what a function is. Okay. Now a function is let's see. A function is mm, basically a self-contained block. So that's run whenever the function is called. So we have a part where the function is defined and then a part where the function is called. Now, in that self-contained block of code, um, the function will do a specific task. But it's not really limited to that one. Usually it's just one specific task, but you can make a function that connects a set of related tasks. So that's actually possible. Um, but the main importance of functions is that it helps lessen our lines of code. a bit because instead of writing out the same code every time, what you would need to do is just call the function and then give it the inputs that you have uh, previously. All right. So another thing about functions is it's because it's more manageable. It's modularized, meaning you can take one out and put it somewhere else and it will still work, right? As long as they have the same programming language and rules, of course. All right. So at this point here, um, this is the part where we are calling the function called print. And let's try this out actually. So we can see that it's calling the function print. And then we are passing something here inside it. It's an argument. And then we see an output. So if we simulate that one here, okay, I'm going to say print and then hello, Damon. All right. So when I run that code, it will show me on the output hello, Daniel as well. So whatever is something that I put here, it will also be shown in the output. Now there are some things that we can expand on. First is what's this data inside? So this is actually called a string value, right? A string data type. Um, we call it a string because it is composed of a string of characters, right? Including the space itself. The space is a character itself. So how do you know that it's a string data type? It has an open and close parentheses, open and close double quotes, right? Beginning and the end. And that's how you indicate that the data that you are dealing with is actually a string. So data types, right? Right now we know one, and that's string. But there's another basic one, of course, it's the number. So it can be a number with a decimal. It can also be a number without a decimal. It depends on you, on your application. All right. Um, let's see. The expression, right? What example that I did before? So we're going to be using the number data type now. If you say 3 plus 8 and then run it, it will show you 11. See? So in cases like these where you have an expression that can be evaluated into one value, um, so 8 plus 3 becomes 11, and then that number will be what is going to be used by the print function, right? So the way that Python works is that it works from the inside out, no matter how complicated your um, location is. Okay. Any questions so far?
None po.
So it's a relatively simple function, but let's try and see the requirements. So again, we know now that it requires what? An expression to print something, whether that expression is a number or a string, okay? Now, if right now the print function is being abstracted from us, right? We know right now that it works by giving it some input, right? That's basically from the user, us, and then passes it to the backend, which one will deal with the data that we have, right? So if we take a look at the print function here, let's try to look for the syntax, the complete syntax. But the next that we're going to learn is how to read a function, the syntax of a function. All right. So this is actually the real syntax of the print function, right? So it says print objects, comma, separator, comma, end line, comma, file equals file, and comma, flush is equals to flush. Now, what does this mean? And why are we only using one? Why are we only using one parameter in ours here? So the way that this works is that the object here has a letter S on it. It indicates that there can be more than one. Okay, you can add more than one for the print function. Next is the separator and the end file. Actually, these four. These four are let's see. So these four are the parameters of the syntax, right? You can treat them like temporary placeholders for a certain value. But you might be asking why it doesn't look like this. Why is it like it has sep is equals to separator? That's because this is how they made it. They made it in a way that we can uh, send out a certain piece of data that's related to this parameter. So let's have a quick example. So it said what? The separator, right? And then open objects. Okay. So let's say we have more than two objects, all right, or two things that we want to print out. How would you do that? So you would just separate them with a comma. And this actually goes with any other function as well. Let's see. All right, so if you want to add another object, you just use a comma and then input the other object that you want. So in this case, there's no restriction on what you want to put next, but usually it's of the same data type. So I'm going to be using my name here. Okay, so now we have two objects, and the condition in the syntax says that object are objects. So as long as you have like um, more than one object, you can use it like this, right? Okay, hang on. So if we print this one out, it will print out hello and Daniel in the same line. Now, if we try and use the sep as equals to separator, it's explained here that it will specify how to separate the objects. So we already know that the objects are these two, right? So the separator, the default value is actually a blank space. This is the reason why we saw a blank space in between, but we just kind of assume that they'll be separate because that's usually how we construct sentences, right? Um, for the sep, right? even though that's a parameter, it's described in a different way. So we call it a uh so separate. If you want to separate the objects, let's say for example, separate them in terms of the asterisk, then you're gonna have to indicate this one because they are called keyword parameters. Okay. So if you say sep, right, and then put an equal sign, and then put another character here, like this one, or maybe a string if you want, for example, like that. So the separator now is equals to these 5 stars, right? Now, if you run the code, you'll see now that the separator between the two objects are um, separated by this one. Okay. Now you can do some amazing things with this. Um, there are some certain applications that can do this, but in this case, we're using a dummy. Okay. What about the next one? Sum the end. So when things specify what to print at the end, default is /n. Hmm. So what does that mean? /n. /n is actually a code in string format that indicates when a part should uh, go down to the next line. All right. So let's see this happen here. Let's see if it goes down. If we make multiple statements of print here, what do you think will happen? If we run the code, you'll see that each line of code is displayed here, right? But this also goes for the other things that it passes here as well. All right. So that's basically how rep the SEP works. The end here, right? If you specify the end as not a /n, so that's short for new line. Let's see. At the end, we want to input this. All right. Something like that. So what do you guys think will happen if we were to make multiple copies of this print statement? So if you do that, unterminated. Okay, hang on. Unpermitted string withdrawal. This one. All right. So this is what the end line does. Instead of, yeah. So instead of the next line, the next print statement appearing on the bottom, what it will do is instead it will uh, do it in the same line. All right. So that's what the end parameter will be. Right. So there's another term that we have to clarify. What are objects, right? So objects are kind of like the king inside of um, Python. So basically, you can consider everything that exists in Python to be an object. All right. So you might be asking, is the number an object? Is the string an object? Is an expression an object? Then the answer is also yes. All right. So object, set, and there's actually no need for us to discuss the last two since it's not really that useful right now. Um, all right. If we try to compare the data here versus the one from Jupyter Notebook itself, just so that you guys can see in Python, right? So you have to go to Python's website and then search for the print function. That's how you'll know what the print function will do. That doesn't come out. Let's see. Let's just go directly to their documentation and then see also this one. All right, and this is the part where we can search the function. So find or print. All right, does it match? How about here? All right, I want you guys to hang on for just a moment. I'm trying to look for something, but I can't seem to find it here. Let's try this one. Maybe this is the one. Ah, yes, here we go. So here's another way to look at the syntax, but this time it's from python.org. And it actually explains here also how to use it. All right. So let's see. I think that's about it for functions. Mm, all right. So we're done with functions. We also know how to read a function now using its parameters. You can just search this one directly from Google and uh, or if you want, just go directly to Python or in this website. This is actually much easier. It's compiled in a much better way than Python does. But in terms of content, this is much more, let's say, complete in its description because, of course, it was made by them. In this case, as long as we don't share that file that it needs, then can't really see it. All right. So I hope this makes sense. For parameters, parameters are actually for protecting your, oh no, wait, not parameters are more like temporary placeholders for something, whether that something will be a string, a value, or something else. All right. So in this case, we have how many parameters? We've had, all right. Okay, so let's just have a quick break for now, guys. Let's have just a quick 5 minute break and we'll be back, right? All right, welcome back, guys. So apologies for that one. Let's see. Let's continue where we left off. So we're done with the print function. Um, so for the rest of the parameters here, I need to show for the rest of the parameters for spawn now. Let's see. Okay. For the file parameter and the flush parameter, uh, just not really use that a lot, so we can just skip that one for now. What's really used a lot is objects, sep, and the end parameter. All right. On that note, so I kept on saying words like arguments and parameters. All right. So there's actually a difference between them. If you say parameters, they are the name given in terms of the function definition. So when you're looking at the function definition, they are the temporary variables that will store the information that we're passing. The values that we're passing are actually the arguments. All right. So these values here, they are the arguments. And then the parameters are these things. Okay. So the set is the parameter and is the parameter. And then these things are called keyword arguments or key value pairs. All right. This is the key. Um, this is the value. All right. The one set after the equal sign. Um, so the way that this works is that for key value pairs, if it's indicated in a parameter as a key value pair, you have to actually call them out by their key. So if it's named sep or end, you have to actually call them by their key, like this one we did here. Otherwise, then it won't be assigned properly, right? Or there will be an error. All right. So let's see. What else did I forgot for print? Mhm. I think there's nothing else. So we can proceed now to input. This is our next function. So let's just write it out here. All the functions that we have learned so far. So we have print. This will basically convert all the objects inside into a string and then displays it into our output section that we have here. So this one. Next is what we're going to learn is about input. Okay. From the name itself, input will basically just accept um, data from the user. Now it has a very simple syntax. When you call a function, inside of a function, you will put there a string. So basically, the string is just a question that you're going to ask the user for, like what data you're asking. So in this case, you can say something like enter your name, and then briefly, there will be a part in the section in the output section where you can input something, and then it will automatically be um, like processed by an input function. So if we try this one out, okay, go down here. If we try input and then say, let's just follow the example, enter your name, something like that. If we run the code, um, this is what will appear on the left. All right. And then the text box here on the right will be where you will put your input. So let's say I'll put Daniel here. But after inputting Daniel, it will just print it out directly because this is what the input function will do at this point. All right. We are just calling the input function, but we're not indicating what else to do with the input function. So Python will just automatically display what we enter. Okay, that's what we got here. If you try searching for the input syntax further, input function, right? Python. Let's just use the one from W3 schools. Yeah, there you see. It's just a prompt. So it's just a default message, or again, the question that we want to ask the user for what data are you gonna ask the user for. So it can be age, it can be uh like grades, subject, whatever, as long as it's an input. So for the objects here in print, yeah, actually I discussed that one. So arguments, parameters, let's change this one to markdown. Right? Okay. I think I briefly discussed earlier what objects are. Let's just go back to that for a moment. So we can treat everything that we have inside of Python as objects. If we say an object, it's a complete description of what that something is. All right. Let's say, for example, we have a car, right? Um, let's have a car as an example. If you were to describe a car, you would separate it into two things. So it would be by its properties and its methods. Now, properties will indicate the car's color, the car's make, the color's is it made out of steel or carbon fiber? What else? Um, the methods of that car are the functions that it can do. Does it have AC? Does it have um like what they call that one? The windshield spray, or does it have a um back window wiper? That kind of stuff. Does it have turbo? So those are the methods or the features of the car. And if you combine those things, right, it's a complete description of what the object is. Okay, that's what an object is for. That's what an object is. Now, in terms of programming, we can't really see that one directly. So if you say a string, we can treat the string as a object. It has properties and it also has methods, right? Properties and methods. Let's put that one here. Methods. Right? It has properties and methods, but we just can't see it directly as of now, right? We'll explore that one soon. But for now, let's just leave it as it is. Okay. What is important is that everything in Python is almost everything in Python is an object. Actually, it's actually the same for other programming languages as well. You can treat everything inside of it as an object because almost everything is an instance of one way or another from another object. Um, yeah. So functions, the terms, what else? Mm, Oh yeah, by the way, parameters will always be separated by commas in Python. It will always be separated by commas, and the values will always use an equal sign to indicate the values for the key value pairs. All right. Again, for objects, when it says objects with an S for print say objects with an S. Usually it's indicated like this. If you are looking at the documentation for the official language that you're learning or the library, it will usually be indicated as something like this objects and then asterisk or S, something like that. So it indicates that it can be as many as you want. So for example, here, Just a quick review. Print. It can be as many objects. So let's use numbers for now, right? I'm just adding as many numbers as I want, as many objects as I want. And if I run that one, it will still print it out. Okay. This all of this here is stored in the objects parameter. Right? Okay. Um, other functions don't have key value pairs. Other functions only have something like this, just a regular parameter. So if it's a regular parameter, we call that one parameter. So we'll divide this one further. Key value pairs, and also for positional parameters. Okay, so in terms of positional parameters, you have to indicate them as they are indicated in the syntax. So for example, if they start with objects and then separator is not a key value pair, then you have to follow that sequence. Otherwise, if they are key value pairs, it doesn't really matter of the order because you are referring to the parameter by name. So for example, here we have this one, right? Set and end. We were to delete this one for now. Okay. If we were to like uh if we were to swap them out, the end and the sep here, okay, like this one, would it have the same output? So if we were to run this one, yes, it will have the same output. See? It doesn't matter the order because you are referring to the parameter by name. If it's not a key value pair parameter, then you have to follow the exact sequence or what we call positional parameters. All right. Let's actually separate those things just so guys won't get confused. Actually, it doesn't matter. Okay. And use two dashes. No. All right. I'll just leave it at that for now. I forgot the code in order to get the next level of a list. So it's only like that. Right. So what else do we have here? Input. Okay. Next is we have int and float, these two functions. I think we skipped something. All right, let's start with the variables first. Okay, so it's not there, but it's an important topic. Variables. So let's put variables here. So when we say variables, essentially these are just like boxes, right? So all of us have boxes at home, things that um, it's where we store stuff, right? Usually when you have boxes at home, you what? Put a label on them. Like for example, kitchen stuff. That's your label. So what do you put in your box? So obviously all the things that are related to kitchen, right? To the kitchen. So that part there is your data type. The thing that should enter the box is something that should be related to the kitchen. So that's a data type that you have. And the box itself is the variable. So whenever you are looking for something, like hey, I seem to have lost my what they call that one, egg beater, for example. And where are you gonna look? So of course you're gonna be looking for the box name, kitchen stuff, right? That's how variables work also in programming. And how do you name a variable? So it's just as easy as naming it directly. Let's say, for example, um, we have this one, right? Name. You can just directly say name, right? And then how do you assign or put a value in your box? You can just directly use an equal sign and then the value that comes after, whatever the value is, right? It doesn't matter what value is. But in this case, I'm just going to put a string. So in this case, Daniel here. Sorry, I forgot the code. Right. If I run this one, it won't show anything. But if I were to type out the variable again like this, it will print out whatever is inside of that variable. See? So the great thing about this one is that I can call the variable anytime that I want, right? Especially for things that are difficult. For example, the pi, right? What's the value of pi? It's 3.1416, blah, 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 right? I can't memorize that one directly, but I can memorize the name. So if I were to call out it by name, pi, right? I can refer to it by its name, all right? Same with people, right? You can remember a person by like their facial features, but you have to put a name to that in your memory, right? In order to make the memory solid. Um, so yeah, let's see. Mm, what else? So variables, right? Um, at which point do we call them? So for example, we have something like this, right? So if I ask you guys, right, there's a quick question. Are variables considered object? Yes or no?
Yes.
All right, good. Who was that? Was that you, Catherine? Yes. So that's correct. Variables are considered objects. So in that case, we can use them in the print, right? So if you use them in print and then you put inside their name, we can actually print them out. So this is actually very useful in a lot of cases, especially if it comes to data analysis later on, where your variable is a representation of rows and rows of data. You're just going to be referring to them by name, and then you can filter them out. Like these are the people with that are less than 18. These are the people that are greater than 18, right? After filtering them out, after processing the data, you can save them into a variable. All right. Now, let's say we have another number here. Let's say num2 in this case, and this will be just a random number point. Um, so we can use that one in processing expressions as well. So instead of writing the number directly, like 3 times 2, for example, you can just use the equivalent um, variable name, so pi multiplied by num2. This is an expression because it can be evaluated into one value. If you run this one, it will be this. Okay, the output will become something like this. Okay. So all you have to do is just call it by name and it will work. Okay. It will even work with key value pairs as well. So that's the important thing here. And on that note, right, what do we do with variables in terms of input? Well, earlier you saw that when I ran the input, it will just automatically output the value of whatever we type. But a better way is to save it again in a variable. So let's say we call it name, right? We'll put it here and then we'll say input and then enter your name, just like with the example earlier, right? Now it makes much more sense. Okay, we type in the name there, enter your name. And then if you print something like hi, my name is, oh, wait, wait, hello, space, and then comma, and then name. So there are a lot of ways that you can do this one. You can use objects and the default set parameter of space. So giving you something like this. So if you type in the name, it will automatically have a space in between. Or you can also use concatenation. So that's another thing, concatenation. Right. So concatenation is just using the plus operator to add strings, literally, not add them as values, add strings together, right? So what are strings again? They are what? A sequence of characters. So if you add another sequence of characters, it becomes one big sequence of characters. That's what concatenation means. So how do we do that in terms of print? So if you can say print and then hello, space, right? And then you can use the plus operator and then the name. This is considered one expression, right? Okay, or one object in this case, because it will be evaluated into one value, and that value is now just an object as well. So if you were to run this code, okay, you can see that the output is exactly the same as this one. See? So there are different ways of achieving the same result. It's up to you, really, if you want to use the default or using something like this. The main point here is that if you change your input to something else, you don't have to change the other parts of your code to adapt to the change in input because you are referring to them um, by variable. So a practical example is for the addition um, operation in math, right? So you have operand one is equals to input, right? Something like that. Enter the first number to add, something like that. And then I'm just gonna copy this whole thing, paste it here, call this operand two, and then enter the second number to add, right? And then let's say we have a print function here at the bottom that will add the two, operand one plus operand two. So that's one object. And before this, let's say that we'll have an object here that says the sum is, right, something like that. And we're good to go. That's all that we need. So right now, what's happening? So right now, our output is dynamic, right? It adapts itself to whatever input that we want. So if you say 5 plus 6, no, wait, 5 and then 6, you get 56. Wait. Oh no, there's a problem, right? What happened? So if you've noticed, why is the answer 56? Can anyone tell me? So I think I remember explaining this one before for the print statement. Can anyone tell me why the answer is 56 and not 30? String, very good. So the input, right, will always convert the value that you enter as a string. So that's a problem, right? It's still a string data type. So what do we do? So here comes int and float functions, all right? So int is obviously for integers. These are the whole numbers that we have. So negative, zero, positive whole numbers. Float or is anything that has a decimal point, all right? So if you put your strings here inside, then it will be converted directly to um their equivalent data types, right? But in this case, in terms of numbers, float and integers are just of the same data type in Python. But in other languages, they are very strict with this. You have to specify clearly if the data is float or int, right? And this is what makes Python great because um, it's not that easy to declare something like float or integer in other languages like C++, for example. Um, you have to do it like this in C++. Okay, just give me a moment. I don't know why my Jupyter Notebook is acting up. And just do a lot of spaces there. What is happening? Okay. In C++, you would do it like this. So you would say int. You're gonna start with the data type, and then you would declare the variable name, right? Var name, for example, and then you assign a value to it. So if you assign the wrong value, it's gonna be an error, all right? But in Python, it doesn't really care, right? When we declare the variables earlier, we didn't even declare if it's an int or a float. It just automatically accepted it as it is. So this is what makes it easier for beginners to grasp programming concepts in Python. All right. So again, with the int and the float, we're going to be using those functions. Let's add them up here. Int, float. All right. So we're going to be using those functions. Let's see, how are we going to use them? So just like with the input, right? After the function is done, so you enter something, enter the input, right? Essentially, this entire thing will be replaced by what you entered and then saved to operand one. Same with operand two. That's what's happening. So meaning, what can we do? We can just wrap this entire thing in an int function. You can say something like int, right? Here, and then also in this case here, int. Okay. Now, you might be asking, how does this work, sir? It looks weird. It's working fine because again, after you're done inputting the number, it becomes what? The input in your input in a string format, and it is automatically passed as an argument to the int function since it is inside its um open and close parentheses. Okay, so it is automatically passed as an argument and processed immediately afterwards. So now our operand 1 and 2 are numbers already. So if we run this code again, and then enter 5, and then 6, it's not actually move. I said multiplication earlier. It's actually plus. So 5 plus 6, and the answer is 11. See? So you have to be very careful with this one. You have to remember what data type you are working at. And right now, it doesn't seem that hard to not get lost. But sooner or later, you're gonna experience something like chains of functions um, that you or some other programmer is using. So you have to trace each one how the data type is being changed because depending on the data type, the function that you can use is also different. The methods that you can use is also different. So you have to be aware every time what data type you are using. Um, but yeah, it gets easier if you keep on practicing this one. All right. So now we have int and float. If you were to use float in this case, would it still work? The answer is yes. The answer is yes. The output will just become something with a decimal number, 11.0. If you were to do this one directly in other languages, it would produce an error, right? So it's definitely easier here um, in Python. All right. So let's take a look at the other examples here. So it's also what it's doing, wrapping the entire input function into the int and then converting it directly into a number data type. On that note, I did not put that here. Okay. So we have what number data type, and then we have string data type. So far, we have only discussed two. For strings, you can declare them in either using double quotes or single quotes, right? It will still work. I just have a preference for double quotes because I keep on switching languages. So I want to like get used to double quotes so that I don't make a mistake in using other languages. But for you guys, using single quotes is actually good enough. Okay, now let's see. This is just a what's this? This is a review of all the functions that we have used so far. The Pi extension, this is what I told you earlier about with the notepad. If you save it as a .py or yeah, .py, it will be it will become a Python script that can run in an IDLE. Just for context, I wonder if I can show it to you guys here. Python, yep, 64-bit. All right. So for the latest version of Python, just for you guys to like see the difference. Let's see, share. All right. So this is what an IDLE looks like. It's roughly the same as what was included in the presentation earlier, but it's slightly different at the same time. So everything that you have learned so far can work here as well. So if you say print and then hello, you're gonna see that it's also gonna show it like this. In fact, with the format here, let's see the greater than symbols. It's also the same, right? So this is the IDLE for version 3.13 64-bit of Python, right? So everything that you have learned so far, it can work here. If you have a script in Python and then run it directly here, it can run. So if you say input and then enter a number, for example, right? And then enter a number will be output, right? But again, we're not going to be using this one since it's very difficult to follow, especially because of the format. It's just pure text. Um, yeah, it's not really user friendly. So we'll just stick to Jupyter Python, Jupyter Notebook for now. Okay. What else? Let's see. This is just a repeat of the flowchart earlier, right? And this is the IDLE, another example of an IDLE. Um, yeah. Hmm. Right. So for errors, by the way, this is one thing that I like in Jupyter Notebook is how they show errors because it's uh, really easy to understand. So for example, I were to use plus here and I were to remove operand 2. It will result in something like this. So how do you read this one? So it will explain in what cell number the error is, in what line, and then it will also indicate an arrow in which it detected the error. So it says that it is in this line, and then print the sum is, so it's here, right? The arrow is pointing here. It says line 4 because it includes the space here, right? It counts the space as a line. And then, of course, the syntax error name. So it says invalid syntax. So you're missing a argument here, all right? So that's how you read a syntax error. Let's see. Mhm, mhm, mhm. I even have the same example. See, 3 plus random syntax, but it doesn't show everything. So here you can see everything. If you were using a different IDE like PyCharm or something, they might have a different look. It might show more information than needed. Usually in those IDEs, they also show where the function was defined. Like we see that the error occurred here, right? But in those IDEs, they also show the inside part of the print function, right? The one that's abstracted from us. So they also show that part in which part of the print function definition, right, itself, in which part there did the error occur. Now, some actually like that one, those that really need to know where the error occurred. But for us, where we focus more on data science and data analysis, it's not really useful for us. So in this case, this is where Jupyter Notebook comes in handy. Okay. You might be asking, will we be using Jupyter Notebook if ever we chose this career, right? Will we be using Jupyter Notebook for professional use? The odds are no. Again, we're just using this one because it's beginner friendly. It allows you to understand things a lot better. But industry standard, you're going to be using those IDEs that I mentioned earlier, like PyCharm, Visual Studio Code, and then you're going to have a lot more on your screens, right? But as long as your foundation is solid, you won't get lost. All right. What else? Chapter summary. All right. So we were able to finish the PowerPoint. So that's our first PowerPoint here. On our second session, we're going to discuss control structures and functions. On our third, these two PowerPoints. Fourth, this one, web scraping, where we will be extracting data from an actual website. And then fifth is for Python Pandas. So it's for transforming data a lot easier compared to normal transformation processes. So I hope you're excited for that one. So this is where the actual data science starts at web scraping onwards. All right. Yeah. So as you can see, we also have machine learning there. You're going to be learning that from Miss Shai. So we kind of just have our own sessions. So I handle the first five channels, second five. So with that, do you guys have any questions so far with our terms, our examples here, clarifications? None. All right. Thank you for the feedback, Gabby and Anthony. All right. And Catherine as well. All right. Let's see, what else can we do? So we still have a few minutes to spare. Let's see. Let's make use of our remaining time. Mm. All right, how about some exercises? Yeah, let's have a quick exercise. I want you guys to do the following. I don't know what's happening with my Jupyter notebook. All right, I have here, yeah, let's do something simple. All right, just to see if you guys are actually listening. All right, so your first exercise will be this one. So exercise number one. One and then right. Calculating the area of the rectangle. It's too big. How about this one? Right. Calculating the area of the rectangle. So I'll leave it up to you guys to decide how you want to achieve this, but it should have an input, right? And then it should also show the actual area of the rectangle as an output, right? So it's up to you guys what units you want to use, what words you want to put as a prompt to the user when asking for the input. The data type is up to you if you want to use float or int, all right? So yeah, depending on the problem, I think it can take you guys just 5 minutes for this one. Yeah. Just in case you forgot, the area of a rectangle is length times width. So, all right. So Anthony has an answer here. So I'm gonna copy your code and, oh wait, I can't really copy your code. Um, hmm, how do we share code? I can't really text format. How do we allow copies in Zoom? For the others, just keep on working for now. I'm trying to look for a way to copy text. Hmm. Sir Anthony, are you running um a Jupyter notebook now or another IDE? If you're running this one on something, maybe you can share your screen so that the others can see your answer. Let's see, all participants. Jupyter. All right. Can you share your screen, sir, so that the others can see your answer as well? So
Yes,
I'll
boss.
okay, I'll stop sharing for now so that you can share your screen. All right, the floor is yours. All right. So it's still loading. Okay, I can see your screen. All right, sir. Can you give us a rough explanation on how your program works?
Okay, sir. Can I be heard po?
Yep, we can hear you.
Yeah, so I assigned float input enter the base of the triangle. Um, I assigned it to a variable which is base, and then I also assigned under the variable height in float input enter the height of the triangle so that whatever we input on both will be converted into a number.
Mhm. Yes.
That's why when I created the formula under the variable area, so it's 0.5 times base times height,
Mm-hmm.
the value we will input under base and height can be multiplied by 0.5 because they were already converted into numbers.
Right.
And that's why when we printed the area of the triangle is um, we got the correct value dahil nga all were converted to numbers.
Right.
So I made use of 5 for the base and 6 for the height. That's why when I multiplied 5 by 6, it's 30. But then we still multiplied that by zero point 0.5. That's why the area became 15.
All right.
That's
So
all po.
that's
Thank
yeah,
you.
that's a good explanation for Anthony. Thank you. How about the others? Do you have somehow a similar solution to what Anthony has? Yes, all right. So that's great. Okay, thank you for sharing, Anthony. I see. But I think I was asking, what was I asking? Um, let's see. Where was my window? Did I say triangle? Because what I have here is rectangle. But anyway, the solution is still correct. That's fine.
Sorry, sir. Sorry.
Yeah, that's okay,
Mali
sir.
ako nabasa.
That's okay. It's still correct, so that's what matters. All right. Next is so since Anthony is done, I want the others to present this time. Whoever can get the answer first. All right. So gonna put this to mark down, and then exercise number 2. But you can still answer if you want, Sir Anthony. I'm just giving the others chance to show their work. What's that doing here? Enter. Calculate. All right. So this is your second exercise. Calculate the average of three numbers. Okay. So just like before, this should take you around 5 minutes less. And your timer starts now. Oh yeah, I forgot. If you guys don't have Jupyter Notebook yet, you can use an online compiler. Let's see. Just in case that you guys are wondering, we have that one here, Python. Oh yeah, you can use the Go Colab at Google. You can use that one directly. Uh, yeah, you can just go directly and search for Python online compiler, just so that you can answer the exercise for today. So we have this one, online Python, right? You can use this one to compile your program. So there's also a run button at the bottom. Okay? Just for those who have no Jupyter Notebook or Anaconda. All right, one more minute. All right, time's up. Who was an answer? Or even a partial answer? That's fine. No volunteers? All right. Okay, there's another one chat. All right, this is from Gabby. All right. Um, so what are you running now, Gabby? Are you running Jupyter Notebook?
Yes po.
All right.
Yeah.
So I'll give you the screen. Yeah, just like with Anthony, kindly discuss your program and explain to
Oh,
your classmates.
wait. Okay po. So here, one of the ways to do it po is simply just to. Oh wait, what happened here? Okay. So first po, we start by declaring three variables for each of the three numbers. So for one po, here's the input for your first number, then the second number, then the third number po. And then after inputting each, it will be converted automatically into a float since the input function is nested in the float function po. And then after that, since they're already a float po, they can be computed with other numbers, including integers naman po. So whatever the value you inputted for the first number and the second number and the third number, first we add them all up po before dividing it by 3 to get the average, since this is the formula for the average po. So
All
as
right.
for example, 5 plus 4 plus 3, and then we get the average of 4.
Okay. Perfect. So thank you for that presentation, Gabby. How about for the others? Do you have the same solution with Gabby? So one here is from Anthony. All right. So it's nice to see that you guys are active with our activities here. Let's see. So for now, like I said earlier, it's still the first session, so it's kind of easy, right? Nothing too hard. But as we go along with our sessions, it's gonna get harder. And then the difficulty will scale up the moment we reach this part, these PowerPoints. So I'm not trying to discourage you, but programming is actually very difficult if you think about it. Um, it's one of the things that you can learn by yourself. But actually, this is actually great for you guys because you have a mentor that you can ask on questions or challenge ideas. So that's great. I actually didn't have one before, so I actually just did everything myself. And it will take a longer time if you do that. So it took me around 2 years to finish web development and other languages as well. But if you had a mentor, it's definitely faster because your path is already laid out for you. So yeah, take advantage of that. And it's already 5, so I guess we'll end it here for now. There's no need for assignments currently. You guys were able to answer the questions perfectly, so that's good. Next week I'll be asking maybe Neil, Catherine, and Paolo for their turn in sharing their answers. So yeah, I hope you guys learned a lot today, and I'll see you next week. The video will be uploaded in YouTube. Miss Moriel will just send you via email the link to those videos, all right, when I uploaded them. Okay, so that's it for today. Have a great weekend and see you next week. Goodbye.
Thank you po,
Thank
sir.
you. Bye.
Thank you. Thank you. Bye bye.
Welcome.
Bye po. Bye.
Bye bye.